So the way I like to present this, and I figure all of you have some experience with Revit, and one thing to kind of realize about Revit is that Revit has basically three editors. So I call them editors. There's a project editor, and most people are familiar with that. We'll start a new project, and we get this, and we've got wall tools and window tools and roof tools and all these parts of a building. So basically, when you're designing a building, creating a project, architectural project, the notion is that you use these elements, you compose these elements to make the building. It's very much construction oriented. We build a wall, we put in a door. So, I can draw a wall by clicking two locations. I can, it's kind of fun because it tends to find the alignments and snaps, makes it very easy to draw something regular. If I click on the little house icon here, I get a 3D view. I see it's a 3D walls. It's all very simple. I can create a floor, go back to my plan view, add a floor, boundary lines like that, and done. Go to my 3D view just to prove that it created one. Yes, there's a floor there. So all very simple. I'm not going to teach you how to do that. There's lots of tutorials out there that can walk you through it. If it's new to you, you can probably learn a whole lot just by clicking on buttons. So works pretty well. All right, now the second editor to be aware of. Now I'm happy to help you with anything in the project editor. So there are some commands that are difficult. The stair command is difficult. The curtain wall command is challenging. Ramps and railings, if you need them, they may be hard to figure out. But roofs have some little quirks to them. So don't, you're very welcome to ask me. Now the second editor to realize is the family editor. So the family editor is for creating family objects. So a family object is sort of a prototype object. And I'm going to get, you see that they're prototypes for balusters, columns, curtain walls, ducts, lighting fixtures, on and on and on. I'm going to get a generic model here. And I get the family editor. Family editor looks a little bit different. So one, it's got these two elements here, these two reference planes, and these reference planes are pinned, so I can't move them. Now, the convention is that, so if you use AutoCAD, you know about making blocks. The blocks have an insertion point. This is the insertion point where these two cross, and you're basically making a block. So until you insert that block in the model, it doesn't exist in your project. So, but you're defining what that family is. So, now you've got all these solid modeling tools: extrusions, blend, revolve, sweep, swept, blend. You can create void forms to make subtractions. So it's pretty powerful at making form. Now, the way to do it properly, and usually the tutorials don't really teach you this. There's some books that kind of go through it, but is to make use of these tools over here: reference lines and reference planes. Now, I can make a few analogies for these. So when I was in school back in the 70s, believe it or not, you know, I took drafting classes and they taught me how to do manual drafting with T-squares, parallel rules, triangles, architect scale, engineer scale, all those sorts of things. And the drafting instructors were insistent that we draw layout lines for everything we drew. So we had a 4H pencil. Anybody know what a 4H pencil is? Taken enough art to know that. A 2B pencil, an H pencil, all those sorts of things. 4H pencil is very hard lead and it makes a very light line. And so you draw everything with this very light line. And when you had it all worked out, you would go back either with ink or with a, you know, HB pencil is usually what we use. It's moderately hard, moderately soft, makes a thicker, darker line. And we would redraw it all with the dark line. So we would draw it twice, once with the H pencil. Sometimes we would use, some of my instructors like to use a blue pencil instead of the 4H. Does anybody know why they used a blue pencil? Blue pencil does not show up, the blue lines do not show up when you print it on a blueprint machine. Blueprint machine uses blue light to make the photographic reaction happen and make the print, and the blue line doesn't show up under blue light. So, but anyway, we would draw everything with layout lines. Reference lines, reference planes are like layout lines. Now that's analogy number one. Analogy number two goes to Le Corbusier. So Le Corbusier declared that architecture always has regulating lines, is what he called them. So every design should have major regulating lines that control the arrangement of the solids and voids in the building. So I think of these reference planes from an architecture theory point of view are the regulating lines of the design. So always draw with the reference planes and reference lines first. So typically you'll use reference planes. And I'll just show you a very simple example. I can draw a reference plane like that and a reference plane like that. Revit's really good about keeping it all orthogonal. That's what I want in this case. And all I want to do is create a parametric square. You'll notice that there's not a square tool in Revit. There's a rectangle tool, but not a square tool. Well, I want a square tool, so let's make a square tool. So I've got basically what looks like a square here, but if I click on this one, it will give me the dimensions starting here and going up to that. So I can make that dimension permanent, and you'll see that again in a moment. Well, let's just do another one. I can make this one, and if I click on this, it says make this temporary dimension permanent. I make it permanent. So now those stay all the time. Now for it to be square, this one has to equal this one. Pretty simple. The way I can do that is I can click on this dimension line, and I get a new menu up here with modified dimensions, and it has label as an option. And this is create parameter. So I'm going to create a parameter. It gives me this editing box here, and I'm going to say it's a family parameter, and I'm going to say it's I'm just going to call it dimension, because a square doesn't really have a length or a width. It just has one dimension. They're the same. Length and width are the same. I'm going to make it an instance parameter. Not really going to get into that today, but a type parameter basically means that if I were to insert a lot of these squares in my model, all of them would be the same size. So I could put in 2-foot squares and they would always be 2-foot squares, unless I changed the type and made them 2 foot 4 inches squares. And then they're all 2 foot 4 inch squares. So the type parameter affects the preserving a dimension or quantity or parameter value among all the instances. Okay, if it's an instance parameter, that means that every instance can have a different size or have a different value for this parameter. So, you know, I realize that the explanation is pretty meaningless, you know, until you start using it, until you get familiar with it, and then it makes sense. So in order to understand this, more explanation doesn't help. Doing it helps. So we're going to make an instance parameter, and I won't worry about shared parameters and reporting parameters right now. I'll just make an instance parameter. So the dimension line changes. So dimension equal 1 foot 8 and 11/16 inches. If I click on this one over here, I can also label it. And if I pull this down, there's that parameter that I created. So if I click on that, it also uses the dimension. And now the two reference planes are locked together. If I move one of these around, the other one moves too. So it's a square. Okay? So that's our very simple parametric relationship. Now I haven't drawn anything yet. This is just reference lines. These are just regulating lines. And architecture is not made of merely regulating lines. So, so I want to create something. And so I want to just create an extrusion. I want to make a cube is what I want to make. So if I take this extrusion tool, then I've got a rectangle here, and I can draw a rectangle. Now watch how I draw the rectangle. I don't try to draw it precisely. I don't care. Sketch it in. I don't care. Be really loose and easy. This is how Revit is actually much easier to draw than most programs, because you can sketch freely and don't worry about the dimensions. AutoCAD sort of forces you into, you know, I want to draw a line. Well, exactly how long is that line supposed to be? It's supposed to be 3 feet 2 inches. Okay. But Revit lets you sketch it. Now the step beyond sketching is eventually I need to align it with my layout lines. So if I click the align tool here, I can click on this layout line and this one and pop it up so that that line is on that one, and I want to lock it together. And I can take this one and align it and lock it, and this one and align it and lock it, and this one, align it and lock it. And now they're all locked together. If I click on the checkbox, I got a 3D cube or 3D block. And if I go here and I drag this plane around, the other reference plane changes and the solid changes too, because it's locked to the reference planes.
Does the height scale with it as well?
The height does not, but let's make the height scale, okay? So to make the height scale, there's a couple of ways to do it. If I click on this, this is the easiest way, in my opinion. If I click on this, I just selected my solid here. And we can kind of see that if I go to a shaded view. And we can look at it over here. But I've got that block. Now you'll notice that over here, it has an extrusion end and extrusion start. So, and there's this weird little box here, and it's associate family parameter. So a cube, the length, the width, and the height are all the same. So if I click on this, I get to pick dimension. And now they're all the same. And if I go here and I move that around, go back to my 3D view, you know, it's still a cube. So now I made the length, the width, and the height all the same. The way, you know, going back through that, that's a weird trick. A lot of people don't know, but there's this weird little associate family parameter. You'll notice that I cannot edit the value anymore because it's linked to that parameter. Now, if I open family types up here, then I see that dimension value and I can edit it here. So I can change the size of all 3 dimensions at once by changing this dimension parameter here. Okay. Now, if I load this into a project, and I've got what's in here. Right. Okay, so I can place these little cubes around. And if I click on that, you'll see that the dimension is over here now, and I can edit the dimension. So 2 feet. And you see that this one changed and the other ones did not. If it was a type parameter and I edited the dimension value, all of them would change. But it's an instance parameter, and so only the instance changes, not all of them in that type. Now, another interesting point is you see there's these neat little drag arrows here, and I can drag this thing around. The drag arrows are related to the reference planes. Where I put a reference plane, there will be a drag arrow. You know, so if I put a reference plane and a dimension on it, then there will be a drag arrow. If I don't put a reference plane with a dimension, there will be no drag arrow. So sometimes, you know, you will probably get in a situation where, you know, where are the drag arrows? And I love it when I can drag it around. Why doesn't it have drag arrows? Well, it may be that you drew the object without having a reference plane there to let you draw it. So the reference plane is crucial for getting those drag arrows. All right, now another thing that is a pain in the neck, most people, tutorials out there are not real good on. I'm going to get another family out just to play with. Is rotating things. I'm not going to go through how to use all these tools. You know, you can look them up. But they're kind of fun. One reason I'm not going to go through them is because I'm showing you the family editor, And the conceptual mass editor is so much more fun. I want to focus on that one. But I do want to show you how to create a parameter that defines a rotation. So, you know, again, we need to draw reference planes. What would be something interesting? Let's do this. I want to make a 5-sided figure with one side kind of chamfered. So it's going to have these corners here, but over here, there's going to be a angle. And I want to control that angle with a reference plane. So what I have to do is I have to create a reference line, because only reference lines can be controlled as an angle with a parameter. So I'm going to create a reference line here and draw from here to here. Now you see it has a dimension here. And if I click on that, well, actually, I need to create a dimension. So I'm going to create a angular dimension between these two, pull it out like that, and I'm going to create a parameter for that. Instance parameter A1, angle 1. Now, if I go here, hopefully I can change that angle. I changed it, but not quite the way I wanted to. You see that it actually rotated around a center point and not around this point. I want it to rotate around this point down here. So I can make it do that by using the Align tool, and I can click on this. I want it to rotate around this intersection. You see, when I get to that point, it lets me find that point. And I can move that down and lock it. And I can take that and lock it. It won't like the constraints, right? I'm just going to back it out to there. Okay, so now I'm going to lock it. And I think it will rotate now. Okay, so I had to lock it to this intersection. And once it's locked to the intersection, it rotates around that intersection. Now, kind of a neat thing here is I can also take this endpoint and lock it to here. And it stretches it. And then if I move this, it gets longer. So now I can control an angle with a parameter. And again, if I want to make an extrusion, I'll probably draw it like that. And a bit annoying, I still have to lock it. and finish it. Load it into my project and see what we can do with it. Change the angle. Hopefully it won't blow up. And this testing step is really important. It's not really working. So we got to go back, see why it doesn't work. That one wasn't locked. Okay. Makes sense. So I press the tab key and I can cycle through the different things that are at this location. And I want this reference line to be locked, or the shape handle to be locked to the reference line. Still not. Yeah, the sketch line. Right. Okay, so it's finding the reference line here. Click on that. Click on it again, it's going to find the sketch line and I'll lock them together. And then we can test it in here. Good. Load it into the project and it should work now.
So basically you had the reference line locked to the angle, but not the actual sketch line.
Yeah, I think I had the sketch line. Yeah, right. So the reference line was not locked to the sketch line.
Gotcha.
I mean, really, the sketch line was not locked to the reference line. And after I extruded it, it becomes ambiguous. Am I clicking the plane, or am I clicking the edge at the top, or am I clicking the edge at the bottom? And it just becomes confusing. You can make it work, but it just, you've got to be really careful. And it was easier to go back to the 2D sketch and lock it to the reference planes and then make the extrusion. And it just, you know, was easier.
Okay.
So there was an edit sketch button up here. If I edit family now, click on this thing, there's edit extrusion. And that goes me to the sketch, the 2D
Okay.
that controls the extrusion.
Okay.
And I forgot to lock this angled one to the reference line underneath. The reference line was being properly controlled by the angle, but the extrusion was not locked to the reference line, so it wasn't controlled. So, you know, the real key is to, if you're going to control it with parameters, draw reference planes and reference lines to control it. Get the reference planes and reference lines to move properly with the parameters, and then go add the model lines to make extrusions and other solids. You know, so the distinction is a reference line or reference plane is a layout line that does not exist in the building, you know, or is only implied in the building. You know, we could argue about that, but it does not exist as a physical object. Model lines and solids exist as physical objects in the real world. And so just respecting that philosophical concept embedded in Revit will make it a whole lot easier. Okay. So, okay, I'm going to stop the share for a moment. And I'm going to stop the recording. And what